Alright, let's get started. I'll give you a quick tour here. So this is my semi-automatic kitchen whisk. It's just a little kitchen tool that I designed. It's essentially 4 parts, well, 5 I suppose. There's a handle, there's these 2 inner collars inside the handle that just retain the handle to the whisk itself, and then there's a foot down here. It's just a little I've got it mated right now for measurements. Let me undo that real quick. Yeah, so this is a little foot. It's just a ball and socket in here to give it a pivot point. So essentially the idea is, you can see it's a bit transparent. There's a helix cut into the handle that makes it so that you can plunge the handle up and down like so, and it causes the whisk to rapidly spin because of these here extrusions on the handle. So I have a spring. This is actually a spring, an exact dimension spring from McMaster-Carr that I got, that is 3 inches long, 1/2 inch diameter, with a 3.77 the lowest sorry, the 6.15 max load. The lowest load spring I could find that was small. Like, it's actually kind of a pain to find something with really low strength like that, but that's what I found. So I kind of just built my design around that. So I have here, we'll switch to the whisk itself. So the idea is, this is something I can 3D print. These exist. You can buy these. They make them with like metal whisks. But I wanted to just do one that I could make on a 3D printer because I want one, and just thought I could design a cooler one than what I've seen. So essentially, this is the whisk itself. This is hollowed out for a yeah, 1/2 inch by 3 inch spring, which is what that spring was. I designed this in a number of steps. So we started by just doing like this paddle, and then cutting the hole out, and then doing some chamfers. And I don't know what that sketch is for, but then went ahead and did a circular pattern. Just added a fillet to them to make them a little cleaner. It didn't want to do the pattern with the fillet, so I had to do it after. Added the handle section. Made it so that, oh, that's just down here in the tip. Added some reference geometry so that I could add these guys, and then cut them out. And that's just these. And it does all that. So that's hollowed out, basically a socket for the foot. We'll do these real quick. You can see it's just, I built it. It's got a 2 inch diameter revolve cut, and it's tapered here. And so this is it's actually not 125. Oh, it is a 0.125. Oh, but that's not actually the reference that matters. If you look at the sketch, you can see the dimension that really matters here is this 0.98, which is actually 0.975, so that I get a nice tight clearance for the foot. So it kind of just pops in like like a ball and socket would. So it pops into place and lets it rotate on the foot, which is just this guy. Yeah, I don't know what kind of tolerances you can really get with the 3D printing. Like, I don't have any experience with that, so I'm gonna have to fine tune this a bit, I suppose, with a few attempts at 3D printing. So here's the handle. This is probably the most intricate part of the whole job. Cut it in half so you can see. So we have this helical spiral that comes up through it, that I have pitched just to match that 30-degree slope that I put on those nubs that stick out on the whisk part. Then the shaft, this inner shaft in here, compresses the spring to let it retract when you let off pressure. So essentially all you have to do is push down on the handle, and it rotates it would be counterclockwise, and then as the spring would re-extend it and make it push back out clockwise, and so it would basically mix back and forth rapidly. You can look them up. They, like I said, you can buy these already. I just wanted to make my own, and this is what I have. I've got a pocket down here for that collar. Look at the collar real fast. The collar's a little interesting. So it's two of these identical, and they just attach to one another. The peg goes in the hole. I put this groove in here because I wanted to use like an O-ring to press it into the handle, but I don't think that's very useful. I don't know. I can't figure out exactly what I want to do. Maybe add a screw, maybe just have it press fit. I haven't decided. I think I just want to play with press fit and see how well it works if it's not taking nicely on the 3D print. See, I want this thing to be able to be disassembled, to be cleaned, because you're going to be getting pancake batter and stuff up inside of it, and I don't want that to not be accessible to wash. So you get it. Essentially, I want to be able to take the collar out so that you can take the spring out and clean everything thoroughly and then reassemble it. And I want it to be easy to disassemble and reassemble. And like a set screw might be the way to go, or maybe have some through pins that go through and lock it in place. I don't know. I haven't decided on that yet. But, I mean, it'll work as is for R&D's sake. It's a good start. But yeah, our little foot is just popped into its socket down here. And so it just, like, yeah, the foot plants on the bottom of the bowl or whatever you're mixing in the glass. You can use this to mix drinks or whatever. And then these, here, we'll do a cross section so you can see. These little nubbins fit perfectly in these grooves, which took some doing. I probably could have done some calculus to determine the exact pitch and stuff for the helix, but trial and error worked just fine. It's one of the nice things about SolidWorks is you can play with it and find something that works for you. But yeah, see, those fit ever so nicely in there with a little bit of room to spare because they don't need to be tight. They just need to be there. It's just a guide more than anything. So yeah, then as it comes down, you see this rod makes contact with the spring, and it would compress it down to here. And that's pretty much the whole idea. I was going to do like manufacturing prints for it, but I mean, where it's supposed to be 3D printed anyway, the manufacturing prints are just the CAD files, right? So this is it. This is the print. I just got to order some of these springs, which are, what did I determine? They were $7.10 for a 12-pack. So probably just get some of these ordered and try and 3D print one of these next semester. I'll come see you and we'll make one, or 12, I guess, since I'll have 12 springs, have some to give away. All right, thanks, Paul. You have a great summer. We'll or have a great Christmas. I'm sorry. We'll see you next semester sometime.